So here I'm showing you how to sketch the graph of an exponential function in the form of y equals to ax plus q. Firstly, we are going to make q be 0. If q is 0, then we will be changing the value of a and look at the behavior of the graph. So firstly, we are going to start with the values of a between 0 and 1. So as you know that a can never be 0 and a can never be equals to 1. So we are going to look at the values that are in between 0 and 1. Start with 0, 1. If we start with positive 0, 1, our graph from the left hand side to the right hand side, it is a decreasing function, passes through the point 0 maps to 1, and it approaches the line y equal to 0. Those are the x-axis. At y equal to 0, the graph is not touching this line, but it approaches this line. Just never touch it. In other words, we have the horizontal asymptote here at y equals to 0. Why at y equal to 0? Because q is equal to 0. So what you have to know is that the equation of the asymptote is y equals to 0 in this case. Generally, the equation of the horizontal asymptote in the exponential graph is always y equals to q. Since q is 0, so at y equals to 0, we have the horizontal asymptote. And then if we keep on increasing the value of a, you can say that the slope of this graph is negative if you put the tangents, so it's getting less steeper if we increase the value of a, that is in between 0 and 1, and this graph is moving away from the y-intercept, so it has become wider. In other words, but the y-intercept doesn't change, it's always 0 maps to 1, and the horizontal asymptote didn't change. The graph is still approaching the line y equal to 0, which is the asymptote, and the asymptote is the line that the graph tends to approach, but it will never touch it. So at 0.9, again same results, but the graph moves away from the y-axis. Then since our values of a are between 0 and 1, the function was decreasing, so we have a decreasing function. Okay, and if you look at the 0.5, if a is 0.5, the same as 1 over 2 all to the exponent of x. We want to change and make 2 be the base. We're going to have 2 to the exponent of negative 1 all to the exponent of x, which is the same as 2 to the exponent of negative x. In other words, if the exponent, which is x here, is negative, you're going to have the decreasing function, as you see. Now let us look at the values of a that are above 1. So if a is greater than 1, like 1.1, the function, it is now an increasing function. 1.2, 1.3, 1.4, as you increase the values of a that are above 1, you see the graph is moving towards the y-axis, and it is becoming more steeper as you are increasing the curve, becoming more steeper. Talking about the tangents, we can put tangents here on the graph. You are going to see that it is becoming more steeper, but again it passes through the point 0 maps to 1, and it is an increasing function. If you are starting from the left, increasing function, and the horizontal asymptote still y equals to q, since q is equal to 0. I hope we have seen that. This is the effect of a. Okay, as you increase the value of a, graph is moving towards the y-axis. As we decrease the value of a, the jar above of a, the values above 1, so your graph will move away from the y-axis. Now let's just look at the effect of q. Let's just make our a be 2. So right now the equation of this graph is y equals to 2 to the exponent of x only. So let's just keep a be 2 and change the y in the value of q now. A is 2, let's change q and look at the effect of q. Just make another equation for q. Y equals to q. Y equals to q. So this is the line of y equals to q. Then let's make it to be a dotted line. Use dash lines, then change the color to be black and this size with 3. Okay, so this dotted line is our horizontal asymptote. Since we know that the horizontal asymptote is always y equal to q in the exponential graph. In the hyperbola graph, there are two asymptotes, the vertical and the horizontal. But here in the exponential, there's only one asymptote, which is the horizontal asymptote only. Okay, so if we increase the value of q, q is 1, the whole graph shift vertically upwards by 1 unit, and the horizontal asymptote will be y equals to 1. If you increase it by 2, so the horizontal asymptote will be 2 because q is equals to 2. So the equation is y equal to 2 exponent of x plus 2 plus 3. Horizontal asymptote is at 3 plus 4. Whole graph shift vertically upwards 4 units. So the horizontal asymptote will be y equals to 4. And the y-intercept is 5 maps to is 0 maps to 5, so it passes through y equals to 5. So that is the effect of q. If q is negative, like -1, the horizontal asymptote will be y equal to -1, -2. So the whole graph will shift vertically downwards by q units. Okay, that is the effect of q in the graph. So thank you very much. I hope you learned something. Thanks.